In this video, I'm going to be talking to you about 4 different polymer manufacturing processes. These are always asked about in the exam. You need to have a good idea about how to describe them, how to draw them, and what they're used for. So we're going to go straight in with extrusion, then we're going to go into injection moulding, blow moulding, and finally vacuum forming in this video. Extrusion. Now I've got a couple of examples to show you in a second, but extrusion is long continuous forms. So I want you to think about gutters, pipes, tubes, conduit. Generally speaking, you might think about it as hollow forms. It can also be used for solid, so rods are often extruded as well. Now extrusion, the example I give in your home that you might think about how it works, is something like one of those Play-Doh characters like the barbershop, where you put the Play-Doh in, you turn the handle and it squeezes the hair out through holes in the head. Or if you squeeze a toothpaste tube, the toothpaste that comes out of the hole at the end, because it's round, comes out as a cylinder. If it was a star shape, it would come out broadly star shaped. Okay, so that's extrusion in simple forms. Now you need to be able to reproduce this diagram and explain 3 or 4 of the key stages. You'll watch a video in a minute about extrusion, but let me just start off by showing you this diagram because it's quite a clear one. You have a hopper. Now a hopper is like a funnel, and the plastic granules, the polymer granules, are chopped up, and you can think of them a little bit like tiny little beads, about 2 millimeters in diameter. They fall down through gravity into this area here, which has got a screw running in it. Now in an extrusion machine, that screw is fixed, and as it rotates, rather than the screw moving forwards, the polymer is pushed forwards through a heated chamber. So on the outside of it, if you imagine it to be a cylinder, on the outside of it is heaters. So as it moves through, that polymer goes from being solid granules into a gooey, treacly mess, which is then suitable for squeezing through a die. Now the die itself is what gives it its shape. It's the hole, it's the opening that the material is pushed through. So we have a die that goes at the end. It's like the nozzle on a syringe or something. It's the nozzle. Again, another example of that might be if you were cake making and you have the bag and you squeeze the icing out through the bag, the bit at the end, the nozzle, has lots of different shapes, and depending on that shape, you get a different profile. So your examples of extruded products are, I've got a bit of PVC pipe, this is polyvinyl chloride pipe. In fact, all of my products are PVC. So you've got a long hollow section, and that would be continuous. So it would feed through the machine, it would actually come out straight. It would be fed through the machine, and it would continue, and it would be chopped to length. So this originally was bought as I think a 20-meter length, but certain extruded products could be longer, others could be shorter. So we've got our extruded pipe, another bit of extruded polyvinyl chloride here, so you can see the profile of that piece of guttering, and that would be continuously extruded. So these are bought in 2.5 meter length, 2.4 meter lengths, but that would be a continuous process. There is a machine somewhere continually passing out lengths of extruded gutter with that profile, and others. Okay, so that's the extrusion of that, and then another example. Okay, so here's a long piece of rectangular downpipe, or square section downpipe. So long, thin, hollow forms, very robust manufacturing process. Okay. So if we go back to our diagram, we've got the hopper, we've got the screw, we've got the die. When it comes out, if it was gooey, if you imagine it to be a kind of a sticky, gooey material, it has to be cooled down so it goes through that transition state and it becomes more solid and holds its profile, because it has to be precise. So it goes through a cooling chamber. Sometimes this is a bath of water, and it's constantly refreshed to bring that temperature down, which causes that polymer to hold its shape. And it's drawn through, it's pulled through in sort of flattened areas. Okay, so it's a continuous process. So if we were talking about mass production or continuous production, you're absolutely scaling right up. You don't do this in small scale really. Window frames, UPVC, which is unplasticized polyvinyl chloride, is a really good example of it. Quite a cheap process because you're working in such large scale. You wouldn't do this on a sort of a very small scale process. The materials used are thermoforming polymers, so they require heat. Here is our diagram. You've got to get this diagram into your head. You've got a hopper, There's your heated chamber, those are the heaters on the outside. That's the screw that forces the polymers forward. There's our die at the front, and then we've got the water cooling chamber. You'll see that on the video quite clearly. There's a really good video of that I'll show you. Okay, here's some good pictures. I think these are great illustrations of dies. So those are what's popped into the machine, and they give the form to the polymer. They give all sorts of really complicated forms actually. It's quite surprising how detailed that can be. Extrusion is also used with aluminium. You wouldn't use the same machine to do it because the temperatures would be so different and the pressures would be so different, but in principle aluminium is an extrusion suitable material in the same way as polymers are. So the machine is not far different in the sense that that die is what gives them their profile. Okay, extrusion.
Hello, we at Technoform Kunststoffprofile are specialists in the extrusion of fiber-reinforced technical plastics. In this video, I'd like to give you a brief overview of how we produce plastic profiles. This machine is called an extruder, and it's used to create molten plastic out of solid granules. Come a little closer, I'll show you how it's done. The process starts by feeding in the granular compound. The screw transports the material through the cylinder. This is surrounded by heating elements. The heating elements and the friction generated by the screw melt the granules into a homogeneous mass. The die is mounted at the front of the extruder. This gives the molten plastic its profile contour as it's pressed through. Calibration with the help of a vacuum unit cools the profile and allows it to set. At this point, the continuous plastic profile can now be cut to the required length. The profiles land on the tilting table. They're then packed onto pallets in reusable boxes or cartons to match customer needs, making the plastic profiles ready for shipment. If you have any questions, or if we can make your life easier by creating a plastic profile for you, please contact us. We always welcome new challenges.
Injection moulding. Now, injection moulding is a really important process because it's used for such a massive variety of products. In our mass-produced society, injection moulding is one of those real sort of game changers as a manufacturing process. It's very quick, it's very precise. It's massively expensive to set up, but once you're set up, you can produce parts very quickly and very cheaply. I'll give you an example. You might get figures of 10,000, 20,000, 100,000 or 500,000 for an injection moulding tool. That's not the machine that does the injection moulding, it's the actual mould itself, depending on the level of precision and whether it is and how it's manufactured and the level of polish. They're massively expensive. So if you were going to spend £10,000 on a tool, a die, a mould, you're going to want to make sure that you're also going to make 10,000 products or 100,000 products so that you begin to get your money back. Okay? If you're only making one product, your product would have to cost that 10,000 or 100,000 for the tool. So you've got to be making mass amounts. So it's suitable for mass production and continuous production. Not for small scale batch production, not for one-off production. Okay, so if you look at the diagram we've got over here, very similar starting point where we've got a hopper where the granules of the polymer go in. You've then got a screw which is rotating continuously. The difference is this screw also acts as a ram, so it can be moved backwards and forwards. You have a heating chamber. So if you imagine that cylinder, it's got a jacket of heaters around it to bring that material to the correct consistency so it's fluid enough. And then once it gets up to temperature, that ram pushes it forward into the two-part die, or two-part mould or two-part tool, depending on who you talk to. Okay? That two-part mould has got a split line in it. So if you look at any injection molded product, you'll be able to identify the split, normally with a little bit of plastic that's been cleaned off, called flashing. And it's then pushed out of the mould, and you'll see those little points called ejector pins. Here's an example of a tool for a Lego injection moulding machine. So there would be another part to that. It's the space between the two bits, and it can be very fine in injection moulding. So if you've got two parts coming together, the injection moulding machine needs a gap to fill. Okay, I'll show you an example in a second. Another favourite example of mine is the Airfix model parts, because this frame is also how the plastic gets from through the whole part. Okay, so it might be injected at this point, but it then flows along here and starts to fill your mould through these gates until the whole thing is loaded up. Okay, so you can see the sprue in action. It happens to also make it a really nice frame for model making, but that's a good example. So it would be injected at one point. I'll show you an example of how you can look on a product and see that it's been injection molded. So if I look at this drum here, this tub here, okay, what I can see at the bottom is at this point I've got a little injection point. Okay, that would be a sprue that's been snipped off, but because this is a relatively cheap product, that hasn't been cleaned off properly. And then if I look really carefully on here, I might be able to see in the corners there's like a little circle here and here, and that's where this finished product has been pushed out of the tool. Okay, so once it's been finished, it's been pushed away. And I've also got, you can't see this in the video, but there's a little tiny triangle, just see if you can see it. There's a little triangle there, and that triangle shows it's got number 5 in the middle and it's got PP. That shows me that this material can be recycled and it's polypropylene. Okay, so an injection molded tool has created that very, very precise, very, very repeatable, really good quality because it's got a polished material in there. So that's a great example of injection molding. The other one, of course, that I've shown you is Lego. Okay, now Lego needs to be able to be taken apart and put back together hundreds and thousands of times, which means it's got to be very, very precise. It's got to be very strong material. This material would be what we call ABS, acrylonitrile butadiene styrene. ABS. It's really tough. Computer casings, domestic products, video cameras are made with ABS as one of their external polymers because it's such a precise and durable material. Okay, so that's injection molded. This is one I think you really need to make sure that you've got the diagram in your head of the injection molding machine. Okay, now in the question that you're often asked in the exam, using notes and sketches, describe the process of injection molding. So you need to be able to show 3 or 4 of the main stages. That would include the hopper, that would include the screw, that would include the heaters, and that would include the 2-part tool. Okay, so what you've got to look at there is a model answer and then the description of the plastic being fed in, as discussed already. Okay, so 4 or 5 bullet pointed parts and then that diagram is what you need to be able to show in an exam, and that should always be your first choice. If you get a range of choices, if it's appropriate, injection molding is one that you need to know. 3 reasons why an injection molding would be suitable for manufacturing for a child's toy shown here. It's precise, it can manufacture in a range of bright colours, so the polymers are available in lots of colours. It's once you're set up, it's very cheap to produce many hundreds of thousands of them. And it's a durable material. You can work with durable materials, so the product can last a long time. You might also gain extra marks by talking about putting the recycling symbol on it, so the material could be recycled afterwards. Okay. 3 reasons why injection molding is not suitable for small batch or one-off production. Okay. Your go-to answer there is always being right. Is it about cost? Very expensive. So you wouldn't do that for 1 or 2 items or 1,000 items probably. Your tool making time would take a long time. So if you were experimenting with stuff, you would probably take many weeks or months for a one-off to make the tool for injection moulding. So generally speaking, that wouldn't be there. And you've got that massive cost up front. Okay, so if you're going to make 100,000 products, then your tool that costs £100,000, each product has to cost £1 even to just make the money back on the tool, the mould making. Okay. quick one about blow moulding then. Blow moulding is a funny process that you would not really think about if you weren't made aware of it, but it's used in so many of our products, and there are two distinct ways of doing it. Both methods that we're going to talk about today involve a space which has a tube of plastic, a tube of polymer inserted into it, and it's then forced outwards by pressurized air. Okay, so I think of it a little bit like if you were to put a balloon down inside a plastic bottle and blow that balloon up, it would take the shape of that plastic bottle. Okay, that's how you fill the mould, by blowing into it and inflating into a plastic bottle. The difference between blow moulding and blowing up a balloon is that balloon would then deflate. What they're expecting here is that balloon, in the form of a parasol, would set into its finished material, finished shape. So if I show you an example, two good examples that you might use for blow moulding. Both of these are drinks bottles. They're also used for things like cans for petrol and oil and stuff like that. So bottles, hollow forms are blow moulded. All right, so two examples, two different materials, but these are both good ones to use in the exam. So you've got HDPE for milk cartons, and I can tell that this is blow moulded because when I look and feel down the side of it, I can feel a split line running all the way down there, and then particularly at the bottom there's a pinch point where it's been snipped off. Okay, and then it runs up here, the split line goes all the way around it. So I can tell that that is a two-part mould which has come together and that's been formed with that. Little bit of writing around it, it's not very clear. It's one of the reasons we wouldn't use blow moulding for really precise objects. It doesn't take up clear edges, it's better for soft rounded shapes. Okay, so this is high density polyethylene, very thin wall section. Another good example to look at is this drinks bottle here. This uses a material called polyethylene terephthalate, PET, and PET has a really good tensile strength. It can take loads of pulling. Now this isn't pulling in some respects. A carbonated drinks bottle is exerting loads of outward pressure. So what that material has to do is it has to force, it has to be able to withstand that pressure by pulling back. That's why tensile strength is important. Not quite as easy to see because this is a more expensive product, but I can feel there's my split line, and I can see it from this side. Now this has also got another split all the way around the bottom of it. So this blow moulding technique probably uses a three-part mould, comes in from the sides and also from the bottom. Okay, because there's another split line down there. Now I can see at the bottom, there's my recycling symbol. I doubt you'll be able to see it, but that's sitting down there. That tells me what the polymer is. So for recycling, that can go into the right bin. And this is done using a preform. So because that neck has to be really stiff, that's made in I think of it looks a little bit like a test tube, and that preform is inserted into the mould and it's then inflated. So with a milk bottle like this, you have a parasol, which is like a tube that runs all the way through. It's a continuous tube, gets clamped, inflated, and it moves on. This is done using a preform because you need that stiff neck. So that preform would be injection moulded first of all. Okay, you'll see the preform version on the video. So either way, parasol or preform, suitable for blow moulding. It's about inflating into the mould. Okay, let's have a look at our PowerPoint for a minute. You can see here, this is the parasol or the preform. It's inserted into the mould. Temperature is checked. Everything's closed up to give you a good seal. It's then inflated using air. It's then snipped and the mould opened, revealing revealing the finished product. Okay, which is then trimmed off. So one of the key words is parasol. You'll see it up there in the red. Parasol. That would be the continuous tube. The other option that we talk about is the preform, which is the test tube with a sort of screw thread on the top. Okay. 3 reasons why blow moulding would be a suitable manufacturing process for the plastic bottle shown here. Thin wall section. Okay, you need a thin shape so you're not using too much polymer, it doesn't get too heavy, you're not using materials you don't need to. Symmetrical, comes in 2 halves, so a mould can easily be produced to form it. Also, it's going to be continuously or mass produced, so it's also worth spending the money on getting a good tool or mould made up for blow moulding. Okay, so you've got cost, you've got material usage, you've got speed and efficiency. Then we've got using notes and sketches describe the process of blow moulding. So that's where we go to our diagrams, and you need to have practiced. There's various diagrams. Let's go back to the previous one. Various diagrams that you can use. Okay, that's probably our simplest one. But you need to be able to sketch those. Okay, we've got two reasons why blow moulding may not be suitable for very precise or detailed products. Okay, now that's because, if you think about it, very, very thin wall thickness, often flexible materials, they don't take up the detail that would allow you to do sharp edges. Also, because of the sort of material and the thin wall thickness, it wouldn't be suitable for parts that have to be snapped together or slotted together because they're too flexible, it would come apart. Okay, we're going to do vacuum forming now. Vacuum forming is a process that you'll have seen in the school workshop, hopefully. And again, this comes up time and time again in exams, so it's worth making sure you can do the diagrams that explain what what vacuum forming is. Okay, in its really simple form, a sheet of material is placed in position, clamped into place to create a vacuum seal. Heat is then applied from above. The material becomes flexible. You suck the air out. Sorry, the former is pushed up. The air is sucked out, and that forces the material around the former. Okay, now you'll watch a video that it all happens quite quickly, but getting that former right, the thing that it's vacuumed over, is really important. Okay, so you'll watch a video. I think the example I give for this is things like yogurt pots, margarine tubs, and the inserts in chocolate where you've got all the different chocolates to choose from. I think those are a good example. Point of sale units also, actually, I always forget that. Point of sale units for like on countertops in shops. And you'll have seen the Darth Vader mask around the workshop probably, or the boat base. Hollow, thin walls, lots of reasons to use vacuum forming. Because it's quite cheap, you know, a vacuum forming machine might cost you £1,000, but in machinery terms for manufacturing, that's quite cheap. So you could make one-off or small batch production using vacuum forming. Relatively low material cost, so your high impact polystyrene, the sheet that we use, doesn't cost a huge amount per sheet compared to some other materials. So if you're someone who's making like one or two props for a movie or for some sort of exhibit in a museum, vacuum forming is a really good one. It's also good for mould making for things like chocolates and sweets, or soap or something like that. So it's a good mould making process as well. It's used on a larger scale for things like if you walk around a clothing shop, the mannequins which are partially formed, not the ones that are standing up, but the ones that are partially formed, often missing their heads, are usually vacuum formed. Some signs are vacuum formed, and things like baths and stuff are sometimes vacuum formed, interiors of vans and panels and stuff. Okay, so vacuum forming, make sure you're able to describe the process. We'll watch a video on it, it all happens quite quickly, but if I go back to my previous one, we've got a heater, we've got the table that comes up and down with the former on it, we've got atmospheric pressure that pushes in, okay, and then the table goes down, releasing the product. You'll see it in the video. I'm going to give you an example. Sorry, I'm going to go back to my previous. I'm going to give you an example now. I'm just talking about former technology. We quite often get food packaging which is vacuum formed. So this is a tub for mushrooms, vacuum formed, and very, very low cost, low material usage. That material, whatever's cut off it, can be reused again. So that is a good example. I'll just use this margarine tub as a better example about how we go about presenting it. So if our former is not going to get stuck in here, we need it to be able to have a draft angle. Okay, if I had that at 90 degrees and then I vacuumed over the top of it, I wouldn't be able to draw the former away. So by creating the original of this with a tapered edge called a draft angle, that means that it can come out. Think about it like a sand castle where you take the bucket off. Okay, your original sand would be the former and the bucket would be the forming. Okay, so draft angle, if you look at that, it tapers. Look at yogurt pots, you'll see the same sort of thing. Okay, so vacuum forming, suitable for small scale production, but obviously this is going to be a mass produced product as well, so it's suitable for different scales. This material, I'm just going to see if on the packet I can see it, probably something like polystyrene, and it's got a very thin wall, very flexible, so really good, mass produced, relatively low cost. Okay.